Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a plane is going on and we are successfully finished the 17 lectures, right? So in a previous lecture that we have discussed about river and swimmer problems or river and boat problems. I hope that you are listened that concept and you are understood that concept. So it is an important concept now. So with that concept, we are successfully finished the relative motion in 2D, two dimension, right? So in today's lecture, that we are going to discuss about one of the important and easiest concept that is projectile motion. So in this session, I'm going to discuss about what is the meaning of projectile motion. So what is the initial velocity along x direction and y direction of a projectile body. So the acceleration of projectile body along x and y direction. So also the velocity of the projectile body after some time t and the velocity of the projectile body at any height h on its path. All these things that we are going to discuss in today's lecture. So my name is Rakesh Kanganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Shall we start the lecture? Okay. So what is the chapter going on? So the chapter is motion in a plane, motion in a plane, and this is the class number 18. Class number 18. Right. So what is today's concept? Projectile motion. Projectile motion. Okay. Right. So have a look. What is the meaning of projectile motion? If any object, if any object is is projected other than 90 degrees, other than 90 degrees with the horizontal, with the horizontal near the near the surface of near the surface of earth, near the surface of earth, then the object makes then the object makes projectile motion, then the object makes projectile motion. Okay, so when the object makes a projectile motion, if you are projected an object other than 90 degrees with the horizontal, then the object makes projectile motion. Have a look. I'm taking a two-dimensional coordinate system. So what is this? This is a two-dimensional coordinate system, x-axis, y-axis. Let us consider this is a point A. Now, if you want to bring the object into projectile motion, you must project that object by making an angle theta with the horizontal, and this theta must be other than 90 degrees. That means theta is not equals to 90 degrees. Then the object makes projectile motion. Then the object makes what now? Projectile motion. Are you getting? So what is the meaning of projectile motion? If an object is projected into an air other than 90 degrees with the horizontal, then it makes the projectile motion. Okay, right. Have a look. The second point, the study of projectile motion is called ballistics. Is called what, ma? Ballistics. Okay. So third point, the projectile motion is also called as is also called as motion under gravity, motion under gravity in 2D, in 2D. Okay, two dimension. Right. So the study of projectile motion is called what, ma? Ballistic. We are called ballistic missiles. The ballistic missiles means what? They make a projectile motion. That's why they are called what, ma? Ballistics. That's why they are called what? Ballistic missiles. So they make projectile motion. They make projectile motion. So the projectile motion is also called as motion under gravity in two dimension. In two dimension. Have a look. Sir, what happened if we project an angle theta is equals to 90 degrees with the horizontal? If you project an angle theta is equals to 90 degrees, that means perpendicular to the horizontal. Then what happened? Have a look. If you are projecting an object, thrown an object perpendicular to the horizontal. So what happens? The object is moves in a vertically upward direction along y-axis. After it reaches to the maximum height, again it reaches to the ground. Again it reaches to the ground. Have a look. This object is moving along positive x-axis. Again, it reached towards the ground along positive x-axis. It making a one-dimensional motion. It is making a one-dimensional motion. What we need? We need two-dimensional motion of an object. Motion in a plane. Two-dimensional motion of an object that we need. So to bring the object into two-dimensional motion, okay, we have to project an object other than 90 degrees with the horizontal. Have a look. At every point on this path of the object is lies in both x-axis and the y-axis. That means the object is making two-dimensional motion. So that's why we have to project an object other than 90 degrees. If you project an object other than 90 degrees with the horizontal, then it makes projectile motion. Then it makes projectile motion. So examples for projectile motion. A javelin, a javelin thrown by an athlete makes projectile motion. Makes projectile motion. So we know the javelin. Okay, so whenever the javelin is thrown like this, have a look. The javelin is moves like this. The javelin is moves like this. That means it makes a projectile motion. The javelin, the path of the javelin is what? It makes a projectile motion. So why it is makes a projectile motion? Have a look. The athlete is thrown the javelin like this. So with respect to the horizontal, it is making an angle other than 90 degrees. Then it makes a projectile motion. So the javelin makes a what? Projectile motion. So second one, the bullet fired from a gun. The bullet fired from a gun. So whenever the bullet is fired from a gun, it makes a projectile motion. Okay. So the third one, a cricket ball, a cricket ball thrown by a fielder. So whenever the fielder is thrown a ball, so that ball makes projectile motion because the projection, the angle of projection of that ball is less than 90 degrees. Then it makes projectile motion. Okay. Are you understood about projectile motion? Okay, sir. So what is the meaning of projectile motion? If you want to bring the object into two-dimensional motion, you have to project it by making an angle other than 90 degrees with the horizontal. Then it makes projectile motion. That means it makes a two-dimensional motion. Is it clear? Any doubts? So pause the video and write this information. I'm going to write the equations for initial velocity along horizontal direction, initial velocity along vertical direction, all these things. Pause the video and write the notes. 3, 2, 1, go. Right. So we are talking about projectile motion, right? So what is the meaning of projectile motion? If you are project an object other than 90 degrees with the horizontal, then it makes a projectile motion. So I'm taking a two-dimensional coordinate system, that means plane. Let us consider this is a point here. So have a look. If you want to bring the object into projectile motion, you must give some initial velocity for that object. We must give some initial velocity for that object. So have a look. From the point A, I'm just projecting one object like this other than 90 degrees with the horizontal. Okay, then it makes projectile motion. It is clear that to bring the object into projectile motion, we must give some initial velocity. We must give some initial velocity. So have a look. I'm taking the initial velocity of the object is u. U be the initial velocity of this object u. Okay. Now it is making an angle theta with the what? Angle theta with the horizontal, and theta is less than 90 degrees. Now this object makes a projectile motion. It is clear. Okay. Right. Have a look. I'm going to write the physical quantities like velocity, acceleration, okay, displacement along x-axis as well as y-axis. So along along x direction, that is horizontal direction. That is what, ma? Horizontal direction. Okay. So along y direction, along y direction. That means vertical direction. Vertical direction. Okay. Right. Important, ma. You must remember these quantities. Okay, so if you are remember these quantities, then you can do any problem easily. Okay, so have a look. This object is projected with initial velocity u other than 90 degrees with the horizontal. It is making the projectile motion. Projectile motion means what? Two-dimensional motion. Two-dimensional motion is nothing but what? Motion in a plane. Now this object is moving with initial velocity u in a plane. That means this initial velocity has both x component as well as y component. X component as well as y component. Have a look. Along theta side, along theta side, this is what? Horizontal direction, x direction. So the initial velocity of an object along x direction, along theta side, resolution of vector components, I told you that, along theta side. So this velocity, this magnitude into cos theta, and perpendicular to this, along y direction, the initial velocity of the object uy is equals to u sin theta. Uy is equals to u sin theta. So we got initial velocity components along x direction as well as y direction. So initial velocity ux along x direction, what is that? U cos theta. Okay, so here initial velocity, initial velocity along y direction uy is equals to, we got u sin theta. Right. Okay, sir. Now I want to find the acceleration of the projectile body along x direction and along y direction. Have a look. We are projected an object and it is making the projectile motion like this. So this is the path of the object. It is moving like this, like this, like this, like this. Okay. So have a look. The object is moving in this direction. The object is moving in this direction. Okay, na? So this is what? The direction of velocity of the object. The direction of velocity of the object. Have a look. Okay. Now on this object, the acceleration due to gravity is acts on downward direction. Is acts on downward direction. But the velocity, the direction of velocity of the object is in upward direction, and acceleration due to gravity acts on the object in downward direction. Have a look. This is what? Acceleration due to gravity. Acceleration due to gravity. All these arrows are what? Acceleration due to gravity acts on the object in a downward direction. So have a look. Acceleration due to gravity on each and every point is acting in a downward direction. Is acting in a downward direction. That means along y direction. Is there any acceleration due to gravity along x direction? No acceleration due to gravity along x direction. That means in case of projectile motion, the acceleration of the object along x direction, how much? Zero. That's it. But along y direction, there is an acceleration. That is how much? Minus g. How much more? Minus g. Are you getting any doubts? Okay, sir. Now I wanted to find the displacement of the object along x direction. So what I have to find? Displacement of the object. Let us say Sx be the displacement of the object along x direction. So we have the equation of motion. Sx is equals to ut plus half at square. So the displacement is along x direction, velocity along x direction, acceleration due to gravity along x direction. Acceleration due to gravity along x direction, 0. Then we got Sx, displacement of the object along x direction, is equals to ux. What is the value of ux? U cos theta into t. U cos theta into t. Okay, right. So the displacement of the object along y direction, sy bar is equals to ut plus half at square along y direction uy ay. So then sy bar is equals to uy. What is the value of uy? U sin theta into t minus half gt square. So ay is equals to what ma? Minus g, plus into minus minus. So this is the displacement of the object along y direction. Now final velocity. Final velocity. So final velocity of the object along x direction Vx is equals to Ux. Vx is equals to Ux. So important. Okay. So write down in case of projectile, in case of projectile motion, okay. Final velocity of the object, final velocity of the object is equals to initial velocity of the object throughout the motion, throughout the projectile motion, throughout the projectile motion. That means final velocity of the object Vx is equals to Ux is equals to U cos theta. Okay, so you should remember. So initial velocity and final velocity of the projectile body in case of projectile motion is the same. What is that? Vx Ux is equals to U cos theta. This is the initial velocity and this is the final velocity. But if you comes to here, so in case of y direction, along y direction, so have a look. This is a point A and this is a point B and this is a point C, let us say. Okay, we have projected an object with initial velocity u and the object is making the projectile motion like this. La 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 la. Right. So in this projectile motion, this point B is at a maximum height. Is at a maximum height. Okay. So now we are projected an object, initial velocity u, and the acceleration due to gravity acts on this object in a downward direction. That means what happened? Its velocity is changes from point to point. The velocity of the object is changes from point to point. In case of vertical direction, the final velocity of the object, the final velocity of the object along y direction, along y direction is changes, is changes. Okay, so from first one, from A to B, from the point A to B, from here to here, so the final velocity of the projectile body is decreases from A to B. So what happened? Decreases. Okay, right sir. Second point, at a point B, at a point B, that means maximum height, at a maximum height, final velocity along vertical direction is 0. Vy is equals to 0. Always you should remember, at a maximum point, at a maximum point of projectile motion, so the final velocity of object is 0. The final velocity of the object is how much ma? 0. Okay, right. From point B to point C, point B to point C, the velocity Vy is increases. Okay, so in case of projectile body, the velocity component along vertical direction or y-axis, from point A to point B, it is decreases. At a point B, final velocity of y component becomes 0. From point B to point C, the velocity will be increases, and the acceleration due to gravity on the object is act on downward direction. Okay, right. Are you understood? Any doubt? Okay, so pause the video and write the notes. 3, 2, 1, go. So right, in case of projectile motion, the velocity, acceleration and displacement components along x direction, that means horizontal direction, and vertical direction, that means along y axis, vertical direction we got. So what are those? So first one, initial velocity of the projectile object along x direction. Along x direction. What is that mean? U cos theta. Okay, right. So just now we are discussing now The same thing here I am writing. Okay, right. Second one, the acceleration of the object along x direction 0. Right. Third one, the displacement of the object along x direction in the form of vector. So what we got? U cos theta into t I cap. Okay, sir. Fourth one, the final velocity of the object along x direction. This is equals to the initial velocity of the object, that is u cos theta. U cos theta. Just now we are discussing now. Okay, right. Have a look. In case of a vertically projected body, what is its initial velocity? Uy is equals to u sin theta. Second one, its acceleration due to gravity. Ay is equals to how much ma? Minus g. Ay is equals to minus g towards downward direction. Okay, sir. Third one, displacement of the object along y direction. Displacement of the object along y direction in a vector form. So we got u sin theta into t minus half gt square into j cap into j cap. So this is the displacement vector along y direction or vertical direction. Just now we are discussed. So have a look. Here we have the final velocity of the object along x direction. Along x direction. So here also we have to find the final velocity of the object along vertical direction. Along vertical direction or y direction. So have a look. Just now I told you that in case of vertical direction, the velocity of the object is changes from point to point on its path. From point A to point B, its velocity will be decreases, and at a point B, at a maximum height, its velocity becomes 0. When the object is moving from point B to point C, again its velocity will be increases. Okay, that means its velocity will be changes from point to point on its path. On its path. Right. Have a look. I wanted to find the final velocity of the object as a function of as a function of time, as a function of t. So for that we have the equation of motion. What is that one? V is equals to u plus at. V is equals to u plus at. So this velocity is along y direction, y direction, y direction. Vy. So here I am writing. So Vy we have to find, that is equals to Uy. What is the value of Uy? U sin theta. U sin theta plus Ay is equals to minus G, minus into plus minus Gt. So this is what the velocity of a projectile object along y direction as a function of time, Vy t. Okay, right. Now if I wanted to find the Vy, if I wanted to find out Vy as a function of as a function of displacement, as a function of displacement. So velocity as a function of displacement, we have the equation of motion. So what is that? V square minus u square is equals to 2as. V square minus u square is equals to 2as. So this is about a vertical direction, y. So Vy as a function of displacement, we have to find uy square. What is the value of uy square? U square sin square theta. U is equals to u sin theta, na? So u square sin square theta, because it has a square. So that is equals to 2 into ay is equals to what, ma? Minus g into displacement. So just bring this term to that side, it becomes Vy square is equals to minus, went to that side, it becomes plus u square sin square theta minus 2gs, minus 2gs. If square went to this side, it becomes Vy is equals to under root of u square sin square theta, simple mathematics minus 2gs. I'm just substituting all the values in a equation of motion. So this is the final velocity component of vertically projected body along y direction as a function of displacement. So this is as a function of time. So that's it. That's it. Okay. We have two formulas. After that, we will solve one problem. With that, the lecture is closed. Are you happy? Okay. Right. Note number one. If you remember this formula, then you can do the problem fastly as well as easily. Okay. The velocity of the velocity of projectile, the velocity of projectile at at any instant of time, at any instant of time. What is that? So note number one, important one. So the velocity of an projectile body at any given time, at any instant of time, at any given time. So what is that? Have a look. So V bar is equals to Vx I cap plus Vy j cap. Vx I cap plus Vy j cap. So that is equals to V bar is equals to, what is the value of Vx? So Vx is equals to Ux is equals to what, ma? U cos theta I cap plus Vy. So velocity as a function of what? Time. So we have the Vy value. What is that? U sin theta minus gt. U sin theta minus gt jk. That's it. हो गया. Okay, so they are given one projectile body. Okay, so let us consider the object is projected with an initial velocity u is equals to 10 meter per second by making an angle theta is equals to 37 degrees with the horizontal at a time t is equals to 2 seconds. What is the velocity of the projectile body? They are asked like that. So just substitute t is equals to 2 here. G is equals to 10 meter per second square. Acceleration due to gravity. U cos theta. U given along theta side. U cos theta. So u value is 10. Cos theta. Cos 37. 4 by 5. That's it. U cos theta value we got. U sin theta 10. Sin 37. 3 by 5. That's it. We got u sin theta value completed. So you will get the final velocity of the object. Okay, so that's why you should remember these applications now. Okay, are you getting any doubts? Easy concept now, right? If you wanted to find the speed given by magnitude of velocity. Speed is given by magnitude of velocity. So magnitude of velocity is nothing but under root of coefficient of I cap square plus coefficient of j cap square. That's it. This equation gives speed of the object. Okay, right. So in case of projectile body, at any particular instant of time, object is at this point. At this point, the component of velocity along x direction is in this direction, and its y direction, velocity component in y direction is in this direction. Now the resultant velocity is given by v. Let us consider this resultant velocity is making an angle alpha with the Vx, then resultant vector V bar, if resultant vector, I am writing V resultant vector making an angle alpha with the Vx, then its direction is given by, where I have to write, here I am writing is given by tan alpha is equals to Vy by Vx. Vy by Vx. Are you able to see the board clearly? Okay. Note number 2. So this is also an important one. Okay. The velocity of an object at any height of the projectile, at any height of the projectile motion. V bar is equals to Vx I cap plus Vy j cap. Vx I cap, Vy j cap. So we are talking about a velocity as a function of height or displacement. Okay. So V bar is equals to, what is Vx? Vx is nothing but u cos theta only. So u cos theta I cap plus Vy. What is the value of Vy? As a function of displacement. So what is that? Under root of u square sin square theta minus 2gs into j cap. That's it, ma. So with these two applications, now we are going to do the problems. Okay, right? Are you understood? Any difficulty is there? So I'm just taken all the equations and I'm substituted in required velocity equations. Okay, that's it. Okay, so write these formulas clearly and neatly. Okay, we will do the problems like right. So pause the video and write the notes. 3, 2, 1. I'm going to rough the board. 1. Shall we do the example problem? Are you ready? Okay, sir. 1. Go. Right. Have a look. This is a given example problem. So what they are given? They are projected an object with initial velocity u is equals to 30 meter per second by making an angle theta is equals to 53 degrees with the horizontal. So theta is less than 90 degrees. Then absolutely this object makes a projectile motion. Okay, sir. So what we have to find at t is equals to 2 seconds, find the velocity vector. We have to find the velocity vector at a 2 seconds. Speed of the particle. After finding the velocity vector, just we have to find magnitude for that. It gives about speed. So angle made by the horizontal, we have the formula tan theta is equals to Vy by Vx. Displacement vector S bar is equals to Fx I cap plus Sy j cap. Already we are find. Okay, just in that formula you have to substitute u cos theta, u sin theta values. That's it. And if you need a g value, use g is equals to 10 meter per second square. Acceleration due to gravity 10 meter per second square. So, right, find the displacement vector. After that, displacement. So, just find the magnitude for displacement vector. It gives what? Displacement. That's it. So, pause the video and try the solution. All the formulas with you. Pause the video and try the solution. Easy problem. 3, 2, 1, go. I'm going to solve the solution. Have a look. Solution. This object is projected by making an angle 53 degrees with the horizontal. First, we have to find what is initial velocity along x direction, along y direction. So, ux is equals to what, ma? Ux is equals to u cos theta. Ux is equals to u cos theta. So, what is the initial velocity? 30. Cos theta. Theta is equals to how much? 53 degrees. So, cos 53 value is how much, ma? 3 by 5. So 5 ones are 5 6 are 6 threes are 18. So ux is equals to 18 meter per second. That's it. Okay, sir. Next uy. So uy is equals to what? Uy is equals to perpendicular to this. Perpendicular to this. U sin theta. So what is the value of u? 30 into sin theta. Theta is equals to how much, ma? 53 degrees. What is the value of sin 53? 4 by 5. So 5 ones are 5 6 are 6 fours are 24. So uy is equals to 24 meter per second. Right. So what is our first question? We have to find velocity vector. Velocity vector at t is equals to 2 seconds. T is equals to how much, ma? 2 seconds. So velocity vector v bar is equals to vx I cap plus vy j cap. Vx I cap plus vy j cap. So v bar is equals to vx. Final velocity along x direction is nothing but initial velocity along x direction. So along x direction, the initial velocity component and the final velocity component are same. So you will get ux I cap plus uy. Velocity vector along y direction. What is that? It is a function of time. It is a function of time. What is that, ma? U sin theta minus gt. U sin theta minus gt. J cap. So v bar is equals to, we have the value of ux. What is that? Ux is nothing but vx. That is 18 I cap plus we have the value of u sin theta. What is that? 24 minus g value and given 10 into time. So time t is equals to how much, one? 2 seconds. J cap. That's it. Any difficulty is there? That's why I told you that. So please remember the formula. Okay. So Vx is nothing but Ux, that is 18. So u sin theta, the value of u sin theta is equals to how much? 24. Okay. Minus 10 into 2 j cap. So V bar is equals to, we got 18 I cap plus 24. 2 tens are 20. 24 minus 20. 4 j cap. That's it. This is what? A velocity vector. So first one is over. So second one is what? We have to find the speed of the particle. So speed can be given by the magnitude of v bar. So that is equals to under root of I cap square, 18 square plus j cap square, 4 square. That's it. So just solve this equation, you will get the speed. Right. So third one, what is the third one? Angle made by the horizontal. Okay. So at any particular instant of time t is equals to 2 seconds. This is vx. This is vy. Okay. So this is resultant vector. Angle made by horizontal. They are asking horizontal. That means vx alpha. Then tan alpha is equals to what, ma? Opposite side. Vy by vx. So tan alpha is equals to vy by vx. So here we have velocity vector. Here we have velocity vector. What is that? V bar is equals to 18 I cap plus 4j cap. 18 I cap plus 4j cap. So what is this? Vx. What is this? Vy. Vx I cap plus Vy j cap. Just substitute here. So tan alpha is equals to Vx Vy. What is the value of Vy? 4 divided by what is the value of Vx? 18. So 2 to the 4, 2 9s are 18. Okay. So alpha is equals to what, ma? Tan inverse of 2 by 9. That's it. हो गया. Any problem, ma? Any difficulties there? No difficulties there, na? Okay. Right. Fourth one. So what is the fourth one? Displacement vector we have to find. So how to find the displacement vector? Displacement vector S bar is equals to Sx I cap plus Sy j cap. So I told you that. What is the Sx? Displacement along x direction. U cos theta into t. U cos theta into t. So Sx is equals to, what is the value of U cos theta? U cos theta is equals to 18. So time t is equals to 2 seconds into 2. So Sx is equals to 36. Okay. So Sy is equals to, we got U sin theta into t minus half gt square. So Sy is equals to U sin theta. What is the value of U sin theta? 24 into t value, how much? 2 minus half g value, how much? 10 into t square, 2 square, t is equals to 2. So 2 get cancelled out. 24 to the 48 minus 10 to the 20. 48 minus 20, 28 meters. Okay, units are meters. So just substitute here. So S bar is equals to Sx 36 I cap plus 28 j cap. That's it. What is the fifth one they are asking? Displacement. They are asking displacement. Just find the magnitude of displacement. So what is that? Under root of 36 square plus 28 square. That's it. Any difficulties there? Simple problems now. So that's why please learn the concepts. Learn the concepts. So once if you learn the concept, then you can do the problems easily. Okay, right. So pause the video and write the solution. 3, 2, 1, go. Right. So this is the end of the today's lecture. I hope that you are understood concept of projectile motion. What is ux? What is uy? What is ax? What is ay? What is the velocity vector at any given time t? What is the displacement vector at a given time? Okay. How to find the velocity vector at any given height h? Okay, now. So all the applications as well as formulas you are understood, right? I hope you are understood. Right. So it's time to say signing off. This is Rakesh signing off. Stay tuned. Jai Hind.